form of life on this Earth depends on the ability of plants to capture the sun's energy and transform it into food. Seabirds feed on fish, and bigger fish eat smaller fish. But somewhere their food chain began with plants. Every food chain is started by a vegetarian. The great African herds of wildebeest feed on grass, and in their turn, they become food for predators such as lions. Plants alone which generate all the food we have on Earth. Without them, ours would be a dead planet. And 4 billion years ago, that's just what it was. Dead. A forbidding, hostile place. Bombarded by ultraviolet radiation. The planet's surface sealed with poisonous gases. Yet in such conditions, strange carbon compounds formed with power to reproduce themselves. From them appeared the first primitive cells of life. Drawing energy from the sun, they began to make their own food, some combining water with a chemical we know as chlorophyll. And this produced an important byproduct: bubbles of oxygen. An atmosphere was being created in which you and I would eventually be able to breathe and live. Two billion years ago, this was the scene where land and sea met. In the next billion years, the oxygen was gradually accumulating, some of it forming a shield of ozone in the upper layers of the atmosphere. At last, the stage was set for life in many forms, and true plants swarmed in prehistoric waters. Now, filter-feeding animals such as barnacles could flourish in the oxygenated water. Life was established in an unwritten contract binding plants and animals together, the green contract. Some animals might live by eating other animals, but every food chain must start with animals eating plants. That is the essence of the green contract. By the time fish had evolved, another stage in the story of life on Earth was beginning. The teeming life of the oceans reached out to the dead land. About 400 million years ago, the first plants came ashore, tiny growths clinging to rocks and mud. In time, they took a firmer hold on land. They developed roots. Plants also developed woody vessels within their stems which made them rigid and enabled them to grow tall. And competition with other plants compelled them to grow taller still. With this dynamic liftoff, the first forests were born. Plants had successfully invaded the land. Their roots broke the Earth's surface and held together the topsoil. And the atmosphere they had created now made life on land possible for many kinds of animals, among them insects. Wings meant that insects could follow the plants upwards into the sky. The first land plants had swimming sex cells and could therefore thrive only in moist places. But by degrees, plants developed new methods of reproduction. The conifers' male sex cells could be carried on the wind as pollen to female cones, which produced seeds. Because they reproduced in this way, the trees could move into new, drier territories. Like an advancing army, they swarmed over the foothills and occupied the high mountainsides, a far cry from the shoreline of the ocean. Forests are conifers. Among them, the largest living organisms, the giant redwoods, capable of growing to the height of a 20-story building. A remarkable development. But there was an even more spectacular one still to come. The plant's male and female parts were combined in a single marvelous device, the flower. Flower pollen is an attractive source of food for insects, and they unwittingly carry some of it on their bodies as they move from one flower to the next. In that way, the flower's eggs may be fertilized. Many flowers produce nectar, which attracts insects, with guidelines to help them find it. Some flowers favor particular insects. The wild arum has a spike with a fetid odor, which attracts small mosquitoes. Many slide to the bottom where the female parts are located. They remain trapped overnight, but next day, the male parts exude pollen. Now the bristles wilt and clear the way for the mosquitoes to escape, well coated with a dusting of pollen that they carry to the next arum. Again, temporary prisoners, they pollinate their captor before escaping once more. The size and shape of certain flowers match the bills of particular types of bird. Members of the parrot family, such as the rainbow lorikeet, have adapted to feeding on certain flowers, and so have become their chief pollinator. Other flowers await pollination at night. In Australia, small nocturnal marsupials called honey possums visit banksia flowers for the sake of their nectar. And by chance, they carry pollen on their fur as they move from flower to flower. The regular traffic to the flowers that feed them is an open invitation to the secret hunters. Some predatory mantids can disguise themselves as flower petals to fool their victims. The killer, poised to strike. Life in the new world of flowers became complicated with many variations on the theme of predator meets prey. In the new relationships linking plant and animal, it was not always the plant which was the passive partner. In some cases, the plants themselves became the killers. Growing on poor soil, this sundew plant gets the nitrogen it needs digesting the insects caught in its sticky leaves. The leaves of another flesh-eating plant form an even more ingenious trap, the Venus flytrap. Press the button, and bang goes the trap. Even so, the plant has no guarantee of success. Win some and lose some is always nature's rule. Each hair is a trigger. Touch it twice, and the trap shuts. Once it has secured its prey, the plant digests it. In all these subcontracts written into the green contract, there is a delicate balance maintained between killer and victim. Individuals will perish, but each species will survive. It is in the tropical forest that there is the richest variety of relationships between plants and animals. The success of flowering plants shows here more dramatically than anywhere else, for they have an ideal climate with warmth and continuous moisture. It is the variety of tropical vegetation that provides such an abundance of food and living conditions to suit an even greater number of animal species. Over 2/3 of all the flowering plant species in the world are found in tropical forests. Eat and be eaten, so the food chain goes on. Body color that matches the background can be a good defense. Slow movers often rely on camouflage. It's a strange fact that this abundance of life often thrives on the poorest of soils. The plants survive because scarce minerals are constantly recycled. Decay, helped by insects and fungi, returns everything to the soil, ready to be taken up again by new life forces in plant and animal. There is one more relationship between the flowering plants and the animals to be found here. After pollination, the flowers are transformed into fruits. Succulent and often colorful, they have evolved to be eaten. Here, wild figs attract large fruit-eating mammals known as flying foxes. While the fleshy part of the fruit is digested, the seeds will pass through the animal's body to be dispersed at random and germinate where they fall. This is a very effective method of dispersing seeds and so creating and regenerating forests. Each seedling will struggle to become a fruit tree and compete for a place in the sunlight. Fruits and berries were also an important survival food for our early ancestors. But even more crucial to human development were the seeds of another very special group of flowering plants which provided the staple food of grazing animals, the grasses. Most plants grow from the tip, but grass leaves grow from the base. So, after they have been cropped by grazing animals, the grass will continue to grow and make more food. Grasses and sedges are flowering plants. It's easy to overlook that. No need for insects. Grass pollen is carried by the wind. When the seeds are set, they contain a nutritious substance which gives them a good start. Grind it up, and it becomes flour, a basic human food that can be stored for months. The wild grasses that we know as rice, oats, barley, and wheat were the key to the growth of human civilization. Drives the combine harvesters is energy from the sun that was processed and stored in the remains of billions of microscopic marine plants in prehistoric times as oil, one of the so-called fossil fuels. Another fossil fuel is coal, the carbonized remains of some of the earliest forests. It provides more than 40% of the world's industrial energy. Into the depths where the prized Black Sea lies. Fossil fuels, coal and oil, contain energy which can be released so easily by fire. The Gulf War focused our attention on what happens when nature is wantonly put into reverse. Originally, when the plants first gathered this energy from the sun, carbon dioxide was used up and oxygen given off to enrich the atmosphere. Now, fire uses up oxygen, while carbon gases pour back into the air. Less violently, it goes on in peacetime, too. Modern transport relies on the burning of oil. The carbon gases discharged by city traffic and industry build up in the atmosphere and prevent the release of heat by radiation, thereby causing a greenhouse effect. Other harmful urban chemicals attack the ozone layer, which shields us from ultraviolet rays, damaging to human skin and also to the plant life of the oceans. Trash, garbage, litter, the dead end of life. What is biodegradable is transformed into a new life cycle. But mankind has introduced the non-biodegradable, the junk outside nature's regeneration, which poisons land and sea. For the first time, a single species, the human species, is threatening the life support systems. We have broken the green contract. But we are at last learning to be less wasteful. As the world's resources shrink, we are recycling more and more. This factory already uses 30% waste paper. Soon, it will recycle 60% waste into new paper. We are also learning how to capture energy without burning fossil fuels or timber. Besides nuclear energy, there is tidal power, solar panels, wind power. We can harness the elements. Our space-age technology can monitor the damage we are inflicting. Satellites report the frightening speed of loss of vegetation, particularly in the rainforests. This is a stretch of forest in Brazil, about 100 miles across. Forest clearance and roads are clearly visible. 3 years later, the same view provides a grim record of the rate of destruction. Time is running out for those research scientists at work up there in the canopy of a threatened forest. Locked away in the chemistry of the rare plants and insects the scientists collect are secrets, perhaps, of medical cures still to be discovered. Our heritage is a pool of genetic material beyond price. This periwinkle comes from the forests of Madagascar. Not very important, we might think. But now, it is cultivated and harvested to make a drug used to treat leukemia in children. Any species we exterminate may be an opportunity lost. Lost forever. By discovering how plants and animals relate to each other, we can enrich our own understanding of life. The rainforest shows us that true life sustains itself within the available resources that it can recycle perpetually. Living in harmony with nature, instead of abusing and degrading it, may demand a change in our habits, but it will bring new benefits. Some of our world's most beautiful sights are under the sea. Even these are no longer denied to us. It seems to be a natural human desire to make close contact with wild animals. This desire is gratified each day for visitors to a remote beach in Western Australia by wild dolphins.
Oh, yes, he's so beautiful. Look at his eyes.
Want to step out, young man, to feed this dolphin?
It's true they're encouraged with food, but the dolphins do seem to enjoy contact with humans as much as the humans enjoy it.
Saying hello again. Hey. She wants some more dinner. Do you know what her name is?
It's cool. Say hello.
You see the trees?
Our world has developed over many millions of years. What gave it stability and increasing variety was an unwritten contract between plants and animals, acknowledging their dependence on each other within a system nourished entirely by the sun. But we can no longer take for granted the age-old rhythms of nature. The growth of human knowledge has given us a decisive influence everywhere, from the depths of the oceans to the sky's final, delicate skin of our atmosphere. It is our actions which will change the world, for good or for evil. In the sheer joy of our existence, we must love and cherish those delicately balanced forces of nature which are enshrined in the green contract. They formed the rules of the created world before we joined the long march of evolution. They hold the secret of our life on Earth.